The system we're working on today, I don't actually know the entire scope of work, so I don't know the specifics about the inputs and outputs on this particular system. I was only asked a question on how we want to set up logic-controlled routing of a signal. In this example, we may have like an office environment that's for employees only, a security environment that's specifically just for security personnel, and a hallway or open environment wherein there might be both employees as well as members of the public. Again, I don't know the full scope of work for this particular job, so I don't know how many zones that really breaks out to. We're going to do this real simple. I've also been informed that there's some mixing of Dante or network inputs in addition to analog inputs and outputs. As far as the physical connectivity of the network and analog ins and outs, those have obvious differences. Once you're inside the device, once you're inside this domain, the digital domain, the device itself doesn't care which one's which. Analog to digital conversion takes place in the input stage, which is represented here, and of course in your analog trim. The network interface has very little to configure because it's a network interface that's already digital. But once it comes out of these, once it's in this domain, it's thoroughly mixable. It doesn't really treat the signals any differently in this domain until it gets back to the output stage again here. So with the exception of your physical I/O on the outside of the device, once you're in here, they're all one thing. It's all treated the same, and they're only really divided here on the screen for the sake of convenience and understandability. So enough with that. It looks like we've gone ahead and labeled these logic sources. These are just momentary contact closures that we can use on the outside of the device to tell it what to do on the inside. We have a Dante source, which I just have as a Dante microphone, an analog audio source, mono, and an analog microphone. I don't actually know what these are going to be in the device or in the real world in this scope because I don't have the scope of work. So in here, you can see that those labels have propagated into the device since we labeled it outside, and we can go ahead and get started on this. The first thing I'm going to go ahead and do is I'm going to bring in some logic-controlled mutes from the left-hand side. So I've just got a logic mute here. I'll just copy-paste it, using usual keyboard shortcuts for copy-paste like you would in any application. In Windows, that's Control-C for copy, Control-V for paste. I'm actually not a Mac guy, I apologize, but it would be whatever you use to do copy paste there as well. So on these things here, we'll do all call, we'll do security, and we'll go ahead and go do security and office. Now you can see in this case it didn't automatically propagate those labels across when I dragged the wire across. So these here are not yet labeled as that. What I can do is I can highlight the wire just by clicking it, and then I can type in the same thing here and propagate and name it as such. Now these here, I don't know exactly which sources are going to be routed to which outputs. You can of course do a matrix mixer, and on the right hand side here you can change the number of inputs and number of outputs on it. So if you need to do any kind of routing in here, that can be done. This video is strictly focused on selecting zones for output, so I'm going to go ahead and not really get into that too deeply. In this case, for this video, I'm just going to assume that you have one Dante mic that's going to all of your channels, and you can kind of figure out what you need to do from there. Now inside the BlueBridge device, signal path tends to flow left to right. So as an example, on this input module that I've got selected here, these represent the outputs from that module. Just like on these little logic mutes, the left-hand side is your input to that module, and the right-hand side is your output from that module. That distinction is important because you can route an output from any module to multiple inputs on other modules. So as an example, I can run this Dante mic like this to multiple different logic-controlled mutes. And you can see that it just simply routes to all of them. That signal will come in from that Dante mic. It'll be processed however you need to process it in there. Or you could add another stage of processing if you wish. But on the other side of this, you can't simply route multiple outputs to one input. You can see that it won't let me drop it there. You've got the little kind of circle with a line through it. And that's of course because it doesn't know what to do with that signal. It won't know how to mix that signal. And for that reason, you can't just simply have your all call route to all of them, not directly. So what you would have to do here is add summers. Summer is exactly what it sounds like. It sums the signals. So we're just going to have a summer for each of these channels. We know that the hallway is going to have a summer. We know that we're going to need a summer for security. We know that we're going to need a summer for the office environment. Now, of course, the simple thing for this is all call is going to simply go to all the summers. All call is going to just travel up to each one. Now, whenever you have an input from the network input, you have the logic controlled mute for the all call. That's going to continue to all of these, and that's going to have audio come out of everywhere. Now you can see that again, none of these are labeled, so I'll go ahead and label them right now, which will make it a little bit easier to understand what we're doing. Now the first thing we might be wondering is, why would you want to have a summer on the hallway one? Now the hallway one may not require a summer, but for example, if you had background music playing all the time, that would enable you to do background music out to the hallway all the time without really being affected by the all call microphone or anything else like that. May or may not be necessary. It's there if you need to use it. Now for the security one, we know that we're going to have it so that of course an all call can go to the security area, but security is also going to have its own separate trigger that can also go in there and only page to security. Now the last thing we're going to do is we're going to go ahead and have security plus office, and that's going to go only to security and office and not to all call. However, what we notice here is that we've run out of inputs on the security one, right? That's easy enough to resolve. First thing I'll do is I'll clean this up a little bit, just give ourselves a little bit more visibility. And the next thing that I'm going to go ahead and do is take this security one, and we'll go ahead and change the number of inputs to 3. And that's just done over here on the right-hand side while the device is selected. So now what I can do is bring up another one here from security and office and move that over here. We'll just go ahead and move these signal paths a little bit so that we can keep them clear. And now I'll label them so that it becomes easier to see. So now you can see that these are labeled. It should be relatively easy to understand, the signal path on each of these. If you need to, you can move these around just by highlighting it and using the arrow key on your keyboard if it makes it easier for you to kind of visualize how it's connected. Move these wherever you need them to be. You can select multiple devices and move them around if you need to make it a little bit more neat so that your work is more understandable. This way, whenever a logic input is triggered, by an outside source, you can go ahead and have that mute or unmute these things. If behavior is opposite of what you had wanted, if it, for example, is not continuously muted and only mutes when a trigger is pushed, you may just have to invert that here. So the invert will allow you to have it so that it unmutes when a trigger is enabled and remutes when the trigger is recontacted. So that's going to kind of depend on how you do that. Anyway, this is really all that has to be done in order to build a logic-controlled mute. And of course, any other kind of processing that needs to go in here will be at your discretion and based on the scope of work being used. So let's have a look at how this would work in a real situation. I've had to make a couple of changes to that just because I, for example, don't have a Dante device in my office presently, so I've used a BB1616. And also because I don't have anything that I can really use as a momentary latch button or as a contact closure, I've just created a virtual one that I can operate using the screen here. And also since I don't have a microphone or any other continuous audio source connected to it, I've just created a sine tone that's going to go through there. And that's going to enable us to see levels on our output stage. So I'll go ahead and move this a little bit out of the way just so we can kind of see everything at the same time. You'll be able to see these levels working for these different zones. You can see we've got hallway security, security, and office. And then what I'll do here is we have these buttons that are inverted, meaning that it's always muted until unmuted by a contact closure. So in this case, for example, if we do an all call, you can see here that we've got, the sine tone is going all the way through to all of the different zones. And of course, this is latching just because I'm using it with a mouse on a screen. In your real world, you'd have a contact closure that's momentary with a button. Security, you can see when I click that or enable that, it only goes to the zone that we have as security. When I do security and office, you can see that it only goes to those two zones and not to the all-call zone or to the hallway zone. So that's kind of an example of how the mutes or unmutes, as the case would be, are going to work. So I hope this has been informative. As always, please feel free to contact us if you require clarification or if you require additional information.